Hello my dear champions, welcome back to our channel Diksha Karnataka. Today I am here with your chapter in Masterstroke, Vector Algebra. Now calculus is completely over. We have done our part for calculus. The last session was on differential equation. Now it's time to move to the simpler chapters, means straightforward chapters, and those are the last two, which is very simple, vector and 3D. Vector and 3D, yeah, they're still high weightage when you consider whether PU2 boards or your CET, in both examinations. This has quite important marks that can be asked, and they're very simple in nature. So we'll try to focus and learn the entire concept of this chapter through this session itself in the Masterstroke. This is a one-shot lecture. This is a concept lecture. The question lecture will come later. Okay. Now I understand even for all of you the question practice is very important. Yes sir, you are giving a concept lecture, but question practice is again very important. Now I have something for all of you, but before I give that to you, you all have to subscribe to the channel right now and hit the like button if you are watching me in this particular class. Okay. So let me give you, once that subscription is done, once a like has been given, let's give you a treat, let's give you a gift. And what is that? Free 4 mock test. It's not one, it's 4. It's one for physics, one for chemistry, one for maths, one for biology. You get free mock test. How to download this mock test? You'll get a PDF directly to be that can be downloadable. Okay. Simply check in this particular video. I've given a sample over here. This is for the Masterstroke session for integrals. You can find, if you go and check the description of this particular session, you'll find similar to this here, free KCET PCMB mock test PDF. Okay, you'll have download link given over here. Click on the link, simply log in with the credentials and get the access to the direct PDF of your mock test for free. Okay, you'll have question paper as well, you'll have PDF also available over there. So do not forget to take this advantage and start solving these papers, solving these questions, right? I'm giving you a concept lecture over here, but it's also important to solve questions, and that's what you got 4 free mock tests right now. Okay. Now what next we have, sir? We have direction cosines and direction ratios right now. Okay, so yes, we learn more of this when we go to 3D chapter. But even in the questions coming of vector, there are some applications, and because in boards what happens, no, or even in your CET, the questions can be clubbed together from these two chapters. Okay, so very important to learn this over here also, as the name suggests. So I'll be very straightforward today, will not go very basic, very mechanical in our process. Will be very straightforward concept approach will keep. Okay, so cos, what it says, cosines means, so angle, if you draw a vector, let's say vector is u, you'll have some angle with the x-axis, y-axis, z-axis. Yes, so when you do that, this vector will have an angle alpha with, let's say, x-axis, beta with, let's say, y-axis, and gamma with the z-axis. Then this values, excuse me, these values are called as direction cosines, and they have a simple straightforward symbol as LMN. L represents the direction cosine of the vector with x-axis, M is what with the y-axis, and N is what with the z-axis. Okay, and of course you all know that very well, but still just give me 2 minutes to recall this. And we have some important property alongside this, from where question actually comes. L square M square N square is always equals to 1. Yes, so with this known that the relation for L square M square N square equals to 1, basically cos square plus alpha beta gamma is equals to 1. This is one of the result, but let me go ahead and tell you one more very important, very crucial result, and that is when you write these direction cosines with the help of their x component, y component, z component across a vector, it becomes what? This is given by, check here, L I cap, M j cap, and N k cap. N k cap. If you use these direction cosines to write a vector, then this result is given by, this is nothing but your u cap. U cap means your unit vector across the vector u. Yes, so if you are using LMN to write a vector, it simply represents a unique vector that is called as unit vector across the given vector u. Okay, which has of course the angle made with xyz as alpha beta gamma. Now before I move on to the next concept, which is direction ratios, we have to talk about, let me talk about something very special for all of you, which will help you prepare for your CET in the most comprehensive way, in the most structured way, and that is our launch of KC30 batch. It's already live. Many have already enrolled into this program. So if you have not enrolled so far, take this course right now, because it's going to be a game changer for your preparation. And right now we also have an offer price going off 2499. After 25th Feb, this price will increase, and because there's something coming up, we'll let you know very soon. In few days you'll know why this date is very important. So yeah, that is there. But right now the price for this KC30 batch is 2499. Features are listed over here. There are many more. Of course, live classes will be there. Okay, we'll be coming here to help you in the live classes. 30 days live online class course. KCET previous year question papers, P by Q. You get P by Q like solutions. We'll solve it for all of you, and then you get complete syllabus revision for both PU1 and PU2. So we'll not forget about PU1, because last year 2021 question came from PU1 syllabus only, and they're very easy ones. Okay, so we have to score a good amount of marks over there as well for CET. So starting with the PU1 portions once your boards are over. Yeah, and this course starts from 21st March. That's very clear. The enrollment has begun already, but the course first class will go on 21st March. And yeah, so chapter wise KCET P by Q in test format. Not only you get the solution of the video, the P by Qs, you also get a live test even for P by Qs. 10 full length KCET mock test will be also given alongside this particular P by Q in test format. Okay, and the classes timing, of course the more detailed schedule will be shared to all of you once you have enrolled into the KC30 batch. Okay, now for everyone who is looking to get also more and more mock tests for all of you, we also have our ABHYAS. We also have ABHYAS test series. This is for again KCET, and this is available at 1499. 1499. So if you want to take both of these, it will become 3999. The price will be 3999 if you take them together. That is also available for all of you. You just have to simply visit the link given in the video description. Go ahead, check the link out, and simply download, simply get the access to the basically enroll into the program and get access to this course on 21st of March. Okay sir, now as I mentioned, we'll learn about DER later. Let's do that right now. So DER is basically this value. Means you have to introduce a constant value with the product of your, means when you take this, check here, if you take L by A, take here L by A, or what is this going to be, M by B, or N by C. This will always be a constant. This will always be a constant. Okay, and if you take them together or individually, actually from here to here, here to here, like that, what happens is the value of A comes as LR. Means, as you can remember, there's the same constant multiplied to each of these, and if it is forming like this, if it was forming U cap like this, Li cap, Mj cap, and Nk cap, your vector U will be given by, basically you write what, LR. So means simply write the value R outside and this as it is as U cap. The R is that the constant of proportion. Okay, over here. Yes, check this out. So L is given by x upon, what is x? The component of across x-axis divided by x square, y square, z square. Means in this case L upon L square, y square, m square, n square, like that. You have to simply multiply and get the result. Okay, so this is for DR and DC's concept. Now we'll look at quickly for the types of vectors. Have a look. Zero and null vector. So vector which has same initial and final point is called as null vector. Okay, check here, AADD. Okay, means the initial point and final point are the same. They are the same terminal point. That's why the vector magnitude is what? 0. Next, unit vector means this represents your direction sense of any given vector. Okay, a vector whose magnitude is of unit length means the length of the, means if you write a vector over here like this, these two are endpoints, right? Let's say AB. This length represents your what? The magnitude. So when this magnitude is 1 and the direction sense is only known from that vector, that is called as unit vector, and this is how you write it down. A vector upon mod of A. Okay, vector A upon mod of A. For example, in this case ijk is given. You simply find A cap as dividing this by mod of all. What is how you going to find mod of all? Simply take 1 square, 1 square, and 1 square. You get simply as root 3. So answer is I cap by root 3, j cap by root 3, and k cap by root 3. Negative of vector, simply change of direction sense. Means if the vector was initially, let's say AB over here, A to B, then the negative becomes what? Same vector, the length will not change, AB will be like this only, but the vector direction will change from AB to BA. This is your vector AB and this is your vector BA. Okay, got it? Very simple concept, nothing much difficult in this. As I mentioned, the chapter itself is very easy. Okay, now co-initial vectors, what is there? So if you have same initial point, the vector is called as co-initial vectors. Next, collinear vectors, if they are in the same, they are the same or parallel support, means I can go like this, okay, even I can go like this or like this. These are all cases of your collinear vectors. Got it? So in that case, we can simply say that the direction sense will remain same, okay, just that length can be or magnitude can be different. That's why we introduce something called as vector A by vector B is equal to some constant lambda, some constant, some scalar value lambda. Equal vectors are said to be equal only when they have the same direction and same magnitude. Both factor has to be same. Okay, means if you have same magnitude as well as same direction, then only we can call this to be equal vectors. Okay, free vectors is the effect of the vector depends only on the magnitude and direction and does not depend upon the position of its origin. That's called as free vector. Okay, great. Some definitions. Now let's move on to solve one question on unit vector. What is this? Vector in the direction of vector is given. They're saying that, let's say there's a vector P. I'm looking to find the vector P, okay, which has direction of this vector. How do you find direction of this vector? Direction of this vector means, let's say this is my vector Q. What's the meaning of direction of the vector? It means Q cap. Understand this. Whenever they say direction of a vector, it means unit vector. Okay. So when they are saying direction, when they are saying that vector P is in the direction of vector Q, it means that I have to find what? Q cap. I have to find what? Q cap. Okay. And they are also mentioning that this vector P has 9 as the magnitude. Okay. Now if I ask you what is the magnitude of vector Q cap, it will be 1. It is unit vector. It will be always 1. So what are they saying? Basically, vector P is nothing but 9 times of vector, 9 times of Q cap. 9 times of Q cap. Okay, let's find Q cap first. You're gonna get this as vector Q upon mod of Q. Mod of Q. You get over here I minus 2j plus 2k divided by modulus. So I get here modulus as 1 plus 4 plus 4. How much is that? 9, which becomes 3. So this whole thing becoming what? This vector divided by 3. I want to get this as my result, vector P. So 9 times of, check here, I minus 2j plus 2k by 3. Answer is this only. 3I minus 2j plus 2k. That is option C. That is option C. Okay, clear? Done? Yes, simple question. As I mentioned, straightforward concept based question can be asked over here, whether it is board or KCET. You got to be patient to wait for those questions, look for those questions and get the result. Okay, come on. Next one. So the same property I wrote over there. Whatever we have taught so far, we are solving the question on those concepts only. Alpha, beta, gamma are the angles made by vector. The direction axis, okay, means they have given direction angles they have given, right? I can find direction cosines from there. Yes, sir. So I can find here cos alpha and cos beta. Actually, if I can write square directly, and cos square gamma. This value is 1. You know that relation we just wrote in the first slide itself. What do you write cos square alpha as? So 1 minus sin square alpha. That's it. That's your answer. Sin square beta and 1 minus sin square gamma is 1. Check here, 1 plus 1 plus 1 is 3. Take minus sign common. You get here sin square alpha, sin square beta and sin square gamma as 1. Right? So simply move this value over there and this value over here. You get 3 minus 1. Answer is going to be 2. Answer will be 2. A very simple question. I know you all know this, but still very important to revise. If you don't know, I hope I've cleared it out. If you still have any regarding this question or the previous one, you can mention that in the comment section. So how did you get this step, sir? I'll explain it to you again. Okay, no problem. Alright, now one more question. Find a vector r equally inclined to the 3 axes. Means when the alpha is equal to beta is equals to gamma. Means the vector u in this case is inclined to all the axes with the same angle. Can happen? Yes, sir. So when this happens, of course, cos square alpha will be equal to cos square beta and cos square gamma. So basically what it means is L square is equals to M square is equals to N square. So alright, this is N square, okay, not N, to N square. Okay, this value is your N square. Actually this is your M square, just to make it clear, there's no confusion about that. Once we get this right, we have the relation sum of all the 3 is always 1. So we get 3L square equals to 1. It means L value is 1 by 3, and we'll have a root. It means plus minus will come. So basically I'm getting the L value as plus minus 1 by root 3, and this is what is going to be equal to M and N also, because they are all 3 equal in nature. Okay, so L equals to M equals to N as 1 by root 3. I'm looking for vector. Okay, so what I'm gonna get, of course, I'll end up with vector R as my vector R cap only. They have not mentioned any magnitude. Okay, they have mentioned magnitude actually. So we are getting R cap first. They have mentioned the magnitude later. We'll write that later. Right now, let's find R cap. So we'll write this plus minus 1 by root 3 times of I, J and K. I, J and K. Now we want to find the R vector. So write this as, what is this magnitude? 3 root 3 into R cap. 3 root 3 into R cap. So if you multiply 3 root 3 by 1 by root 3, you will get what? 3 only left. So answer will be option C. Check here. Your R cap is this value, I plus J plus K divided by 1 by root 3. 3 root 3 is this value, magnitude given. If you multiply these two, you will get root 3 cancel, only 3 R will be left. Basically 3 into I, J, K will be left. That's your answer, option C. Okay, clear? Great. Next, addition of vectors. Okay, so basic concepts are done. Now we'll move on to 2 major concepts from this chapter, which is addition of vector and product of vectors. Okay, because when we talk about parallel vectors, perpendicular vectors, that's where the question comes from. Now, addition of vector, we have 2 rules. We have triangle law of addition and parallelogram law of addition. So this is very important because even in the case of parallelogram law of addition, we use the triangle law of addition to get the result. Okay, so triangle law of addition is very simple. If you have, let's say this is my starting point for the first vector, OA, and if I have this vector, let's say as B, and this is my vector B, it's very important to know that the vector has to be attached head to tail. Check here, this is the head of the vector, this is the tail of the vector. If you have a vector like this, and let's say like this, you cannot add these using the triangle law of addition. You either have to move this vector over here backwards and then add, or you have to move this vector over there, this over there, or this over here. You have to attach the vectors head to tail only. In triangle law of addition, attachment is always what? Head to tail. That's how you get the angle and everything. Okay, once you have that, then the resulting vector is given by simply joining the initial point of first vector and the final point of the last vector. So this will give me the final result. As I mentioned, initial point of the first vector, which is point O, and final point of the second vector, which is B. So you join it from O to B, and this will be your resulting vector. Let's say I get here as vector R. So vector R becomes vector A plus B. This is your triangle law of addition. This is your triangle law of addition. Okay. Next, parallelogram law of vector addition. As simple as that, same thing. If you have the vector attached in this format, let's say this is your, basically the vectors are as the adjacent side of parallelogram. Okay, so where this is my vector, let's say OA and B, this vector A, vector B. Okay, now you the angle between them is also given as theta. Okay, then you want to add these. What you do is basically translate this vector or localize this vector OB over here. Localize this vector OB over here, and then you join this. Let's say this is my point B dash, and then you join OB dash, same direction sense, like this, OB dash. Then this will be my vector R, same result. This is your vector B, because when you localize a vector in the same plane parallelly, it remains unchanged. Okay, means vector B is transferred parallelly in the same plane. It is not changing its magnitude or direction. So it will be vector B, this will be vector A. Now you can use triangle of addition to get the result as same, A plus B. So the sum C or vector R, you can call this to be C also, is given by diagonal of the parallelogram. This OB will become what? Diagonal of the parallelogram OABB dash. This is your parallelogram actually. I hope this is clear. Yeah? Moving on. Let's solve a question on this. So ABCD is a rhombus whose diagonals intersect at point E. It's a rhombus. Sorry, it's not, doesn't look like a rhombus. I'll try better. Yeah. This is a little bit okay, right? Yeah. So ABCD is a rhombus. Okay, and diagonal intersect at the point E means, let's draw the diagonals first. This is my diagonal at the point E. Okay, saying that EA plus EB, they're adding the vector form now. EA plus EB. EA is where? EA is this. EB is this. They're saying plus EC and ED. So EC is over here, ED is over here. So if you are adding all these vectors, what are you doing? You're adding these vectors, EA plus EB plus EC and vector ED. Then you're adding these vectors. What happens? Check here. Check here. So basically we know that length EA is equal to magnitude of the vector EC. Reason is what? What is the reason? Because we know the diagonal of a rhombus bisect each other. Means the length EA and EC are always equal. Okay. Same way, ED and EB are also equal. So magnitude of EB, what is it? And the magnitude of ED are also equal. So in that case, and they are what? We also know that. So if the magnitude is equal and direction is all just opposite, we can write that EA is nothing but minus of EC, and same way EB is nothing but minus of ED. If you use this in the equation that they've asked us to find the value for, you get what? EA and EC cancelled, EB and ED cancelled, answer will become 0. We are using the property that diagonal of the rhombus bisect each other. Okay, have a look. Moving on. Now scalar multiplication means when you multiply a scalar number, 3, 4, root 3, whatever we did, no, 3 root 3 we multiply to the vector r cap. So same way, if you multiply scalar number m, okay, to na or mna, like that, we'll see that. Okay, so if you are multiplying a scalar number which has same sign as the vector, okay, then what will happen? Or it is positive in the nature, means when the lambda is more than 0, then the direction of the vector will not change. Okay, if I have, let's say, lambda more than 0 and this is my vector OA, okay, then lambda, this is my vector A, then lambda A will be of course of different length. If lambda is 2, the length will become 2 times. Okay, but direction will remain same. Direction will remain same. But if you have lambda value as less than 0, then if OA was that, you'll get this as actually AO. Direction will change. Okay, means depending upon the scalar sign that you're multiplying, okay, to the vector, the final sign of the final sense or direction sense of the vector will be affected. Okay, now properties. Associative law means if you multiply n to a first or multiply m to a first, then you multiply n, does not affect the result of a scalar multiplication to a vector a. Now if you distribute a scalar over product with the vector, means m plus n times of a, it remains same as ma plus na, and if you multiply m, which is a scalar, to two vectors sum, it becomes simply ma plus MB. Multiply M into A first, then basically distributing the scalar over the over the sum, means product over the sum, and this is sum over the product. Okay, got it? Condition for two vectors being parallel. Two vectors are said to be parallel if they have this condition true. If you recall this is same as your collinear vectors. Okay, means A by B, vector A by B will be a constant M. Okay, so it can be either positive or negative depending upon the sign of the whether it is opposite in direction the vector A and B, or in the same direction vector A and B. Okay, so we'll have that sense based upon the value of M over there. Okay, now if M value is positive means same direction sense, if it is negative means opposite direction sense, of course. Vector joining two points. If you have vector with the point, if you have the point with the coordinate x1, y1, z1, and second point q with the coordinate x2, y2, z2, then vector pq will be given by difference of these two, x2 minus x1. So if you have over here, take this out, this is my origin, p is over here, x1, y1, z1, and q is over here as x2, y2, and z2. Okay, then how you write vector OP first? Very important, and OQ also, and then comes the PQ. So when you write OP, you go like this, always like this. X1 minus, what is the coordinate of this point? Is the origin, so 0, 0, 0. So x1 minus 0, that's x1 only. Same way, x2, y1 minus 0, so y1 j cap, and z1 minus 0 means z1 k cap. Okay, same way you can write OQ also like this. Where is it? Yeah, x2, y2, z2. Now when writing PQ, when writing the vector PQ, right? Yeah, check here, vector PQ, and I have here, what is this? If I draw the triangle again to show you triangle law of addition, I draw triangle again. So this is my vectors. Okay, I want to find the vector PQ. Okay, and let's say this is my O. So I have to go like this. Let's say I go like this because I want to use triangle law, means I have to go head to tail, and let's say use this as my resulting vector OQ. So to get OQ, I have to go like this. OQ will be equal to what? OP plus PQ. OQ will be given by OP plus PQ. So I want to find the value of PQ, means I'll move OP over here. So OQ minus OP. OQ minus OP. The triangle law of addition. You have the components x1, y2, x1, 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 y1, x2, y2 like that. Take the difference, you get the vector PQ. And how you find modulus? By taking the square of components in the square root as sum. Okay, done. Simple concept of how to find vectors, magnitude as well as the vector, exact vector, using two given points with triangle law of addition. Next, section formula. Important concept using basically, so this is going to be used in your KCET, and in boards the derivation comes. Derivation is important in the boards. 3 marker. This will be a 3-mark question if it is coming for PU2. Right? Okay. Now, so again, this is a formula for internal section. When you have, so this is a figure given for external section, meaning, sir, check, the point P is lying outside the line AB. The point P is outside the line AB, means the section created over here is external section. If you talk about internal section, this is how it goes. This is how it goes. Check. Okay, we have O, A, B, and this is my point, let's say P, and the ratio is what? M is to N. They've given that, right? Ratio is M is to N. In that case, what will happen is this will be my vector A, my vector B, and my vector R. R represents your resulting vector of the point P, which creates a section of M to N. Means basically over here you can see AP vector to PB vector is what? M by N. M by N. Okay, yeah, basically I'm talking about the magnitude side only, doesn't matter. I'm not talking about with respect to the constants. Okay, this is clear. I can cross multiply and get the result. It becomes NAP equals to MPB, and you can find the value of AP from here as, check here, what will be AP, sir? AP will be R minus A. AP vector will be R minus A. We can use the triangle law in the triangle OPA. So I'll have r minus vector a, and over here what will this be? M times of PV. PV will become what? B minus r. B minus r. If you simplify over here, you're gonna get this result only for internal division, for a ratio of a Gaussian vector of the point P from the, of course, origin in the case of internal division. Okay, so you get MB plus NA by M plus N. This is for internal division. What about external division, sir? In this case, you can see that point is outside. This will end up with this MB minus NA upon M minus N. Okay, and this is very simple the midpoint formula, where M and N is what? Excuse me, 1:1. 1 second, sir. Yeah, when M to N is M to N is 1:1. In that case, check here, value of M will become what? Simply 1. So B plus A by 1 plus 1 is 2. So this is my answer for same result with the help of midpoint formula. Clear, sir? Very clear, no problem. Okay, moving on. So derivation is important for your boards. Now, scalar or dot product of two vectors. One of the major and most important concept of this particular chapter is this itself. So if you have two vectors, vector AB, I can write this as x1 I cap, x2 j cap, and x3 k cap. Okay, and vector, let's say I have a PQ. I'll go like this. Sorry, I have written this as x1, x2 now. Yeah. So y1 I cap, y2 j cap, and y3 k cap. Then what happens is, my dot product is given by, means AB dot PQ is given by this formula. AB magnitude PQ, excuse me, PQ and cos theta. Means if this is my, okay, 1 second, AB, okay, and this is the vector, I have to write the same point actually. We write this with AQ actually. 1 second. Yeah. Like this. AQ with the angle theta between them. Then the value is given by, it's not Q, this is theta actually. 1 second. Then this is how you write it. Cos theta. Okay, you can take the magnitude of the value. How you find magnitude? Root of x1 square, x2 square, x3 square, okay, and into root of y1 square, y2 square, and y3 square taken as sum. This is how you find it. Okay, but when you take the component form, when you take this in the form of just components, then you have this result. Please check. So when you multiply these two together, dot product, multiply this with this, so you'll get x1 times of y1 I cap. Check here. So you'll get what? x1 y1. You'll get what? 1 second. You'll get x1 and y1, first one. Okay, because when you're doing I dot I, when you multiply I dot I, you're gonna go like this: mod of I into mod of I and cos of theta. What is mod of I? 1, sir. Mod of I again 1, sir. And cos theta means angle between I and I will be 0 degrees. So cos 0 is cos 0. And cos 0 is what? 1. So 1 into 1 into 1. So that's why I dot I is 1. So is j dot j, and so is k dot k. So I dot I, j dot j, k dot k is always 1. But if you go like this, I dot with j, check here. What happens in this case? I dot j, I get again modulus as 1, and angle between them. So cos of 90. Correct, no? Mod of I is a unit vector, no? So you're gonna go like this as simply 1 and 1, and cos, angle between them I and j is what? X-axis and y-axis, so will be 90 degrees. Cos 90 is 0. Means this whole thing will become 0. So I dot j is 0, so is j dot k, and so is k dot I. So I dot j dot k, and k dot I is always 0. So we don't multiply this one with y2, because if you multiply x1 with y2, it will become 0. Okay, x1 with y2 will be 0 because it is I dot j. So you just simply multiply the likewise components, means x to x means I to I, j to j, and k to k in the case of dot product. So you get here x1 y1, x2 y2 and x3 y3. This is the result of a vector, excuse me, one second here, result of AB dot with AQ. AB dot with AQ, either in the form of definition or in the form of the rectangular components or the components of x, y and z. What happens in the case of perpendicular vectors? It means vectors are like this. Okay, angle will be what? 90 degrees. So you'll have cos theta as cos theta as 0, cos 90 will be 0. So basically if you write here same thing, AB dot with AQ, answer will be 0. If you want, you can reduce the component also. So you'll have x1 y1, x2 y2, x3 y3 as 0. That's my result. Got it? This is the result of scalar product, and this is how you got it, and this is how you get it, and this is the perpendicular vectors result we're going to use to solve questions also. Okay, let's move on. Okay, so look at this again. If you have a dot b, it becomes positive if the angle is in what? In the second quadrant. So 0 to pi by 2, angle between the vectors is acute. Sorry, not in the second, this is first quadrant, my bad. This is the first quadrant, will be what? Cos of the first quadrant angles will be always positive in nature. If it is in the second quadrant, then it becomes what? Negative. What is this? 90 to 180 degrees will be, the cos of that will be negative in nature. So you have less than 0, and it is 0 when it is pi by 2. Okay, so based upon the nature of the angle, acute it is positive, obtuse it is negative, and when it is 90 degree, answer will be 0. Okay, now square of a vector, what it means is basically multiplying a vector to itself. So if you take over here a dot b, or if you have a square of vector means what? A dot a or a square. It's not a dot b, it's basically a dot a. Means a square is nothing but what? A dot with a. What it means is basically a and cos what? Cos 0 degree, because angle between the vector to itself will be what? 0 degrees. So answer will become cos 0 is 1. Simply you get the value as a square. Check, this is the value. Okay, the squaring means simply take the angle to be 0 and take the value of the square. Dot product of two vectors is called as the same vector is called as squaring the vector. Now scalar product of two vectors in the terms of rectangular component, already given you this. Please check, bacha, here. Already said with this, all of you. Yeah, simply take the components, the product of the component of across x, y, z axis. A1 with b1, a2 with b2, a3 with b3. That's the result. Got it? Because I square is going to be 1. Same thing, no? I dot I, j dot j, k dot k. Okay, will be 1. And I dot j or j dot k, this is, and I dot j, j dot k, k dot I will be always 0 because of cos 90 degrees. Now angle between two vectors, same concept is used. Remember, if you have a dot b is ab cos theta, you can find the cos theta as by moving modulus of ab on this side. Modulus of AB on this side. AB means modulus of AB. So A dot B upon mod of A into mod of B is given by the cos theta. So if you want to find the theta value, simply take the cos inverse of A dot B upon mod of A and mod of B. Check this out. This represents your A dot B part, and this is the modulus part. These are the modulus part. Clear? Right? A dot B is A1, B1, A2, B2, A3, B3 from here, and this is what? This is the modulus of A1, modulus of B. Clear? Okay. Next, one question on this. Mod of A is given as 3, mod of B is given as 4. Find the value of lambda for which this is perpendicular to, this vector is perpendicular to, let's call it to vector x, this to vector y. We are saying x is perpendicular to vector y. It means that x dot y will be 0. X dot y will be 0. Check here. So we have a plus lambda times b dot with a minus lambda times b. Okay, got it. Now check here. If we get a square for the first one, mod of a square, then we get a times of this, so minus lambda a dot b. If I multiply this with this, I multiply these two together, we get plus lambda b dot a, and the last one minus lambda square mod of b square. This is cancelled. This value is given as 0 because of perpendicular in nature. Correct? Lambda a dot b or lambda b dot a, opposite in sign, will be cancelled. What is the answer coming as? Have a look. Mod of a square means 3 square minus lambda 4 square is 0. It means 3 square equals to lambda square 4 square. So I get 3 square by 4 square equals to lambda square means lambda value is what? Plus minus 3 by 4. Option B is right. We don't have minus 3 by 4 over here. Option B is the right choice. A very simple question in vector algebra. Done? Moving on. Projection of a vector on a line is given by, if you're looking to get what? This, let's say vector B. I want to get projection of A across this vector B. I have to take this angle into consideration, or write simply as A cos theta. Okay? Or you can simply get this result as dot product of A with B cap. Dot product of A with B cap. Okay? Got it? Same fashion. What is B cap going to be? B vector by mod of B. Alright? And if you're looking for B on A, you have to go opposite this direction. Okay? This is your component. A component on basically projection of A on B. Okay? And B on A will have the same result. Of course, this will be translated on this side. If I take B on A, I'll have B over here, I'll have A over here, and this will be this. I want to take this component, so it will become B cos theta, or simply B dot A cap. B dot A cap. Check. A dot B cap for A on B, and B dot A cap for B on A. Yes, this is the same result on that. I just wrote it right now. You can check. A cos theta, B cos theta, I don't know. Same thing comes from here. Check here. Mod of A cos theta will give me the first component A1, A2. This is what? A1, A2 is my direction ratios. A1, A2, A3 represents my direction ratios. We can obtain that by taking the dot product of this vector A with what? The vector I, j, k individually. When you take with I, means take the component of this across this. You're going to get what? A dot with I upon mod of A into I. Mod of A into I is what? Mod of A. So you get here simply this also as vector A dot with I. Check here, what is vector A? You'll have vector A as given over here A1, A2, A3. Multiply this with I cap. You'll get A1. Multiply this A2 with J into I. It'll become 0. We have K cap into I cap will be 0. So we'll have only this value will be nothing but, check here, only A1 by mod of A equals to what? Cos alpha. So A1 represents what? Mod of A cos alpha. What does this mean? It means the component of the vector A across what? X-axis. A1 represents the direction ratios, the component of the vector A across x-axis. Same way, component of the vector B across x-axis, vector A across x-axis is A mod of A cos beta and mod of A cos gamma. Okay, it follows that scalar components A1, A2, A3 of the vector are the projections of vector A along x, y, z axis. Simple concept. Next, vector or cross product. The next concept is, first one was very important, in product of two vectors, dot product. From there I got a result for projection of perpendicular vectors. Now we're going to move on to what? Cross product, and we are here getting the result for parallel or collinear vectors. We'll see. Definition is this. Very important. This line is very, very important. Check here. It says vector C, which is nothing but cross of AB. Understand this. Result of dot product gives me a scalar quantity, a scalar result. Okay, result, I'm telling you again, result of dot product is scalar in nature, but result of cross product of two vectors is always vector in nature. That's why even A cross B is a vector, some vector C. Result is also a vector quantity. And how do you find this value? Mod of A mod of B sin theta. Sin theta. Sir, this is a modulus, means scalar, and sin theta is also scalar. Where is the vector? So vector comes using n cap. What does n cap means? It means that if this is my vector A, this is my vector B, okay, then n cap represents the vector coming out of the plane. N cap will be the vector coming out of the plane like this, or inside the plane like this. Check here, A cross B. A cross B is, the thumb is pointing it outwards. If I go B cross A, I'll go inside the screen. Okay, so A cross B represents, this n cap represents the vector perpendicular to both the vectors A and B. Okay, n cap is the unit vector perpendicular to both vector A and B. Okay, n cap is for the direction sense and the other part is the magnitude. So A cross B is a resulting vector C, will be having a vector form, and that is given by mod of A mod of B sin theta n cap. Okay, this is the definition part. Now when you go and talk about rectangular components, again then this thing changes to this one. You have to use determinant to get the result over here, and what you do in this case, simply write first row as ijk, the rectangular components ijk, and write the first vector coefficients, so a1 a2 a3. Same way write the vector b, b1 b2 b3, and solve this for determinant. You'll get this as I1 across this for j and for k. You'll get this as your resulting vector C. Okay, got it? Let's look at some properties of vector product. First one, A cross B and B cross A are not equal. Okay, they'll be opposite in sign. A cross A is 0. Why A cross A is 0, sir? Because you'll have mod of A and sine 0. It will be 0. Sine 0 is 0. Okay, so A cross A is 0. A cross B plus C is what? A cross B plus A cross C. Distribution of the multiplication over addition. Product over addition. Distributive property. Next, if you're multiplying a constant x with A cross B, if you multiply x with A or x with P, doesn't matter, result remains unchanged. Again, very simple, if you have two constants x and y as scalar values, multiply in any way does not affect the cross product. It will be always A cross B times xy or xy times of A cross B. This is an important result, very important. If you are taking cross product the whole square, and basically this result is like this: cross product of A and B the whole square plus dot product of A and B the whole square will be given by simply square of individual values, magnitude individual values. How come, sir? If you take this, you're gonna get what? Mod of A square mod of B square and sine square theta. Remember, mod of A square mod of B square sine square theta. Over here, mod of A square mod of B square cos square theta. We have mod of A square mod of B square common, and you get sine square plus cos square. How much is that? 1. How much is that? 1. So you get what this remaining? Mod of A square mod of B square. Same result is over here. Very important. I cross I, j cross j, I cross and k cross k is always 0. Okay, but I cross j is k. How you go about this? Simply write here I, j and k. If you go beta in this order, I to j, j to k and k to I, it's always positive. If you go from I cross j, result is k cap, positive k cap, means basically if you go I cross j cap, result is k cap. If you go j cross k cap, result is I cap, and if you go k cross I cap, you'll get j cap. But if you go ulta, if you go opposite, means if you go I to k, it is negative. If you go k to j, it is again negative. If you go k to j to I, again negative k. Means if I go like this, j cross I, answer is minus k. Just giving a sample. This is the result how you multiply the rectangular components. Okay, two non-zero vectors A, B are collinear if and only if A cross B is 0. Okay, moving on. Because sin theta will be 0 over there. Because sin pi is also 0 and sin 0 is also 0. Any sin n pi is 0 and sin 0 is also 0 for any integers basically. N equals to any integer, sin n pi is always 0. Okay, this is how you find the vector product in terms of, what is it, components. If you need to find the result of this, means magnitude, you got to take square of these values and take in the root. Next, the knowledge hub. So these are the important questions that comes in your KCET. Have you seen these questions? Of course, area of parallelogram is given by, if you have two sides known for the parallelogram, simply find the A cross B and take the modulus of that. Okay, if A and B are adjacent sides, it's very important to highlight this. If A and B are adjacent sides, then answer is given by A cross B the modulus. But if they are diagonals, if A and B are diagonals, then you have to find A cross B modulus divided by 2. Okay, area of triangle is given by, if A and B are the sides, half of A cross B. Okay, now a question on this property. What is this going to be? Check here. Property was A cross B the whole square a dot b, the whole square equals to, what is this? Mod of a square and mod of b square. We want to find this value, so take the square of this, 16, 4. Answer is 20. So option D is correct. Option D is correct. Okay, and this completes your class for the vector algebra. Okay, I revised all the concept. I've taken some questions to help you understand this as well. More classes, more questions for CET will come later. Right now we have to focus on PU2 preparation. That's why the live will schedule after your PU2 boards are over. Okay, but we'll do the questions, don't worry. We'll start from here itself. Okay, so with this I can end the class today. Help us understand your problems better by putting them in the comment section. You'll get the class notes in the WhatsApp channel. I hope you've joined it. If not, join right now. If you're watching for the first time, subscribe to the channel and get more access to all the contents for free on our platform, Diksha Karnataka. I'm your Ankit sir, helping you with the mathematics on our channel. Again, I'll see you in the next class. Till then, take care. Bye-bye.